Okay, looking at probability with counting techniques, which a lot of times to make this simple, we use tree diagrams. The first question they asked us was just what would the probability be of drawing 3. So each time we're going to draw 3 in this experiment, and all 3 of them being cat eyes. So we just took the probabilities of the events, right? Because there's a total of 20. We knew that the probabilities would affect each other because we're not replacing them in the bag. So the first one, let's say this was white, was 7 out of 20. The second one, black, was 5 out of 20. And the third one, which was our cat eyes, CE, was 8 out of 20. So obviously in the first round, we need to take the 8 out of 20, right? Second round, same idea. The only difference is there's now less marbles. Because we've taken a marble out, the probabilities will all be at a 19. And we didn't draw any white marbles, so there's still 7. We didn't draw any black, there's still 5. But we did take a cat eye, so there's now only 7 cat eyes. And again, we wanted to follow that route. And then on the third draw, we wanted to get 3 cat eyes again. We've now drawn 3 marbles out. So now, sorry, 2 out, so we're still out of 18. Again, none of the white or the black have been drawn. So the probability of grabbing them has increased as we go through the experiment. And the probability of getting a cat eye continues to decrease. And because, again, we've drawn 2, it's 6 out of 18, and we just multiplied the 3 of those together. So the next question then asked us, and we'll pay a little more attention to this one, is probability, we'll call it probability of A, of being no cat eyes. Right? So this one, you might think, okay, I draw 3 cat eyes and I can just subtract that probability. And actually, when we did this probability, it was approximately 0.05, right? 5% chance of getting 3 cat eyes in a row. That wouldn't be the case because we can always take a cat eye in the first round, then a white, and then a black, right? And we still draw on a cat eye. So there's many routes here. In fact, I didn't draw the other parts of this tree, but these branches are going to multiply by quite a bit. And in fact, we're going to end up with, because it's 3 levels of 3, so because there are 3 choices here, by another 3 choices, by another 3 choices, it's the same idea as 3 to the power of 3. We have 27 choices in the end, okay? To go through all the ones that no cat eyes are drawn, we can always either go through all the branches of the tree or try running the experiment with just cat eyes versus something else. So in this case, let's rewrite the tree diagram experiment, okay? And we're going to just lump them into groups. You either grab a cat eye, which is at first 7 out of 20, so we're going to say yes, or no cat eye, which would be 12 out of the total of 20, right? Because that's what the 5 white and the 7 black added up to. Was that right, or is it 5 black? Oh, sorry, I wrote those backwards. 5 black and 7 white. They all add up to 12. So the probability of not grabbing a cat eye is 12 out of 20. And this is the route we want to take. Okay. Then route 2. Well, we have choices again. We either yes, grab a cat eye, which is we never grabbed one first, so we still have 8 choices, but the amount has decreased in this question. Or we have an 11 out of 19 chance, right? And that's the route we want to take again. And then finally in round 3, we still have 2 choices. We can either grab a cat eye or we don't grab a cat eye. And probability of grabbing a cat eye is increased again to 8 out of 18. And the probability of not grabbing a cat eye is dropped to 10 out of 18. And it changes every time because we're not putting the marbles back in, right? So in this case, we're going to multiply the 3 fractions we had together. So we had 12 out of 20 by 11 out of 19 by 10 out of 18. So do you want to try that on that calculator there? Because I know the one on the computer is not the nicest for these ones. 18. I can do the fraction part. 13, 20. What did you get?
0.1929.
0.1929.
29.
So 0.1929. which is approximately, we'll say 20%. 20% chance of not grabbing any cat eyes, which is really different from taking this 5% and just subtracting it from the total probability of 1, right? Hence why we redid this experiment.
Yeah.
Right. Does that idea make sense?
Yeah.
Yeah. So using our counting techniques, we can always rename the experiment. We don't always have to stay with the first diagram we go with. We can redraw it. Like in the first diagram, we always had 3 choices. In the second one, we made it simpler, just 2 choices, but the probabilities were different. We lumped black and white together because they are considered just not cat